Hi, this is Mr. Martin with another video, this time on trigonometry. Trigonometry is used in various wave functions, music waves, sound waves more properly, ocean waves, all sorts of different waves use trigonometric functions. It's also used in space. But before we get to those complicated types of things, we got to talk about just the simple roots of trigonometry, and that's the purpose of this video. So trigonometry is actually coming from a measurement of triangles in terms of similarity. And so how does triangle ABC relate to triangle ADE? Well, they're similar because they both have right angles and they both share angle A, which is theta. And so no matter how I adjust triangle ABC, smaller or bigger, it still has that right angle and it still shares angle theta with triangle ADE. So those triangles are similar by angle-angle similarity. Since this is true, how does the ratio of AB over BC compare to AD over DE? Well, AB as a numerator and AD as the numerator of the two different fractions, those are corresponding sides. BC as the denominator and DE as the other denominator are also corresponding sides. And so what I've got is in comparison of two corresponding fractions in similar triangles, which then means that those are equal ratios. And I could also have that be true for AB over AC, BC over AC, or any combination of those two different sides. And since that's true, what that tells me is that any right triangle, if I know the angle, then I should know and can set up information to keep track of the ratio of any side to any other. Therefore, if I know the angle and just one side of a triangle, I should be able to figure out my other sides. All right triangles then with a fixed angle are similar because of this relationship that I show you here. All right triangles, when you know a fixed angle, are similar. And so because that's true, if I know the angle and then I know one side, using trigonometry, I can find the other sides because that is the ratio that that side has to do with other sides. That's the definition of trigonometry. These ratios are then called trigonometric ratios. A lot of times we just say the trig ratios for short. Okay, the common trig ratios are the sine, the cosine, and the tangent. And when they're spelled out completely, they're pretty phonetic types of words, but you'll see them on a calculator and abbreviated in other areas with three-letter abbreviations. The sine is abbreviated SIN, the cosine is abbreviated COS, and the tangent is abbreviated TAN. Now, you would not sound very intelligent to be saying the sin of the angle. Sin is something bad that you do. It's not something you work on in math. Cos, again, is not something you work on in math. It sounds like you're, I don't know, being lazy and talking about the cost. You haven't quite, what's the cost of this? I don't know. How much does it cost? And tan sounds like you're talking about a color or the pigment of your skin as that changes as you spend time out in the sun. No, I would read these as sine, cosine, and tangent even in the abbreviated form. Okay. Now, in talking about trig ratios, I want to be able to talk about my sides in a normal format. In a right triangle, we often call these two legs and this the hypotenuse. The hypotenuse is always opposite of the right angle. It's always the longest side in a right triangle. Well, since that's always true, I'm always going to label my hypotenuse, and I can abbreviate it with three letters here also, HYP. Once I've labeled my hypotenuse, I want to differentiate my legs somehow. And one way that we've done that is long leg and short leg. But more commonly, when you're talking about trig, you talk about the leg in terms of the angle that's given. And so this angle theta that I know, in terms of this angle, I have a side that's next to it, and I have a side that's far away from it. Well, far away from it we would call the side that is opposite of the angle, and so we can abbreviate it OPP or just call it the opposite leg. The other leg would be the side that's next to it, and we say adjacent or abbreviate it ADJ. So the adjacent side connects to the angle, and the opposite side does not connect to the angle. The adjacent side is never labeled as the hypotenuse because the hypotenuse is always what it is. Now if I changed this angle here and said now I want to talk about this angle in my triangle, well, this is no longer the adjacent side. It is not next to the angle. This one is next to the angle. And now this leg is the opposite leg because it's far away from that right angle. Or not right angle, far away from the marked angle there. Okay, so connecting to algebra, you have some lines and you have the slope of the lines. Well, the slope is defined as the rise over the run. The rise, in terms of the angle of elevation or angle of incline of this line, we might measure that angle of incline in relationship to a horizontal line here. And so I create that right triangle. If I know this angle measure, the rise over the run would then be called, in terms of trig, the opposite side, because it's opposite of my known angle, over the adjacent side. The adjacent side is the run in terms of this known angle. And so opposite over adjacent is a trig ratio, and the slope, or the opposite over adjacent, is defined as the tangent of the angle. Well, let's practice finding tangent here. This one's already shown. Tangent of the 27-degree angle is the opposite over adjacent, and then using my calculator I find tangent of 27. Make sure that it's in degrees mode when you do that, and I get 0.510 if I round it to the nearest thousandth, and my habit is always to round to the nearest thousandth on trig. So 0.510, and then my opposite side is 8, so I replace opposite with 8. My adjacent side is x, so now I'm going to solve for x. To do so, multiply both sides by x, and I get 0.510x is equal to 8. And now divide both sides by 0.510, and I get x equals 15.701. And I've rounded to the nearest thousandth here. Over here, going through that, I know I have the opposite that I'm trying to find. I have the adjacent that I know, and so that tells me I'm using the tangent of this 43-degree angle. Tangent of 43 would be opposite over adjacent, or found with opposite over adjacent. From the calculator, rounded to the nearest thousandth, tangent of 43 is 933 thousandths, approximately. The opposite is labeled y, so I replace opposite with y. The adjacent is 12. To solve this, all I want to do is multiply both sides by 12, and I get that y is 11 and 191 thousandths as the rounded value. Okay, so here's a couple of examples on how you would calculate tangent. And tangent can happen off of a coordinate grid like this, or it could happen with any given triangle, so long as you know the opposite and the adjacent. Okay, the sine of an angle is defined a little differently. The sine of an angle is the opposite side again over now the hypotenuse. And so in this triangle I have the angle. From that angle, x is my opposite side, 8 is my hypotenuse. So the sine of theta is opposite over hypotenuse. That tells me on this triangle to find the side I'm going to use the sine. So I say sine of 27 equals opposite over hypotenuse. From my calculator I find that sine of 27 is 0.454, and I replace opposite with x, hypotenuse with 8. And then to solve this, multiply both sides by 8, and you get that x is 3.632. And then over on this triangle, I have the opposite labeled as 16, the hypotenuse labeled as W, and so I'm going to use my sine. Sine of the angle 43 is equal to opposite over hypotenuse. The sine of 43 is 0.682. The opposite is 16. The hypotenuse is W. Multiply both sides by W to solve this function, and I get 0.682W equals 16. And then divide both sides by 0.682, and I get that W is 23.460. And finally, the cosine of an angle is defined as the adjacent side over the hypotenuse. And so in these triangles, you'll see that I know something about the adjacent side and the hypotenuse. And then those angles are labeled. And so up here, we'll start with this one. Since I know adjacent and hypotenuse, the cosine of that angle 42 is equal to the adjacent over the hypotenuse. Substituting in from the calculator, 0.743 is equal to, then the adjacent's labeled W, the hypotenuse is labeled 16. Multiply both sides by 16, and I get that W is about 11.890. On this last example here, the cosine would again be what I'm trying to find, because I have adjacent as known and the hypotenuse is unknown. Cosine of 31 is adjacent over hypotenuse. Relabeling those, that then gets me 0.857 is equal to 8 over x. Remember, my calculator must always be in degrees mode when I'm calculating here. We will later use radian mode, which is a different way of measuring an angle, but that's not for now. To solve then this equation, I want to multiply both sides by x, and I get 0.857x is equal to 8. And divide both sides by 0.857, and I get that x is equal to 9.333 rounded to the nearest thousandth. That's the way that I would solve my trig ratios and the work that I show to support my thinking so that a reader can follow what my thinking was. And finally, a way to memorize or keep track of which trig ratio is which, and that would be the sine is the opposite over hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. And so we commonly talk about something called SOHCAHTOA. That is the phonetic way of going through the trig ratios there. So part talking about sine opposite and hypotenuse, ca talking about cosine adjacent and hypotenuse, and the tangent talking about the opposite and the adjacent. And so if you memorize this funny little phrase, SOHCAHTOA, you'll be able to use that. All right, so this has been the video. Hope it's been worthwhile for you, and hopefully you learned a lot about trig.